Okay, so we have a word problem about fencing a field. It says someone, John, has 480 yards of fencing and wishes to enclose a rectangular area to enclose, and then they give you a picture. So this case right here, I have a square or rectangle right here, and they describe that this side as the width and this side as the length. This automatically means that this other side is the other width and this other side right here is the other length. And what they want is to express the area as a function of the width. Well, I know the area is the length multiplied by the width. So this is the area as a function of both length and width. So I have to find a way to get rid of the L. Well, I know that we'll be using 480 feet of fencing, and so therefore I know that 480 feet of fencing, the total distance around will be, I have to use 2 times the width plus 2 times the length, right? The perimeter is 2 times width times 2 times length. And I can use this to figure out what L is. And so I will subtract 2W from both sides. And so I will get that 480 minus 2W is equals to 2L. And I'll divide by 2. And so I get the length in actuality is 240 minus W. Since I now know that this is the value of L, I can plug it in to my area function. The area is equals to 240 minus W multiplied by W. This simplifies to area is equals to 240W minus W squared. And that's the answer to the first part right here. Find the area as a function of the width. The second thing they ask you, for what W is the area largest? So for what width is the area largest? Well, whenever we're talking about largest or greatest or biggest, we're talking about the maximum. And if I look back at my area function, I'll notice that I have a negative. A is equal to negative W squared plus 240W. I'll notice that this graph right here is a parabola that opens downwards, and so it has a maximum. The maximum point is the apex of the graph, which is known as the vertex. And this right here, W, that gives you that, comes from a lovely formula. That is the axis of symmetry, minus B divided by 2A. So the W that will maximize will be minus 240 divided by 2 times negative 1. A is negative 1. And so that gives us, not 240, 120. And so the width that maximizes the area is 120. And then the last thing is, what's the maximum area? You just simply plug in the W. And so the area at 120 will be negative 120 squared plus 240 times 120. And that will give you, after 14400. And this right here will be your maximum area, the largest possible area. If you plug in any other width, you would get an area that's smaller than this amount, which is the nice thing you have right here, because you can do some powerful calculations. There's a similar question, the next question in line, the last question in the section, and it's similar. It says a farmer has 4,500 meters of fencing. So it starts out the same way. Again, it's a rectangular plot, but this time he's not fencing every side. So what happens is he has a plot, but over here there's a river, and because there's a river over here, he doesn't need to fence that side. So they call this side X. They call this side down here 4,500 minus 2x, and they call this side X right here. And then they say what's the largest area that can be enclosed. First things first, a note about this part right here. This comes from the fact that there's 4,500 meters of fencing. You have two x's, two sides, and then you have a third side down here, which I will call y. If I solve for y, i.e. subtract the 2x from both sides, I get that y equals 4,500 minus 2x. And that's how they got the length of the third side. The remaining part after you've used the other two sides. Now that I have this right here, I know my area is length times width. The area is length times width. X times y is my area. But I know that y is equals to this. So my area is equals to x times 4,500 minus 2x. Similar to what we had a while ago with the w. And so we get the area is equals to 4,500x minus 2x squared. And of course, that is negative 2x squared plus 4,500x. So again, a function that opens downwards. The question wants us to find the largest area. But before we can find the largest area, we have to first find the x that maximizes the area. And that goes by minus b divided by 2a. And so that's going to be negative 4,500 divided by 2 times negative 2. And 4,500 divided by 4 is going to be 11,025. Now that I know that that's my area, I just plug it into the formula. So to find the area, negative 2 times 1125 squared plus 4,500 times 1125, and that gives us the maximum area. Square meters. And that's the maximum area that my friend can fence by adjusting the sides x. Okay, well then, happy hunting.